In this video, I'm going to show you a quick and simple way to analyze structured data that you maybe are pulling from an API or you already have in a data set, database local to your system, whatever, a CSV file, and how you can prompt and drive a large language model to analyze data for you. So I'm going to do this with real estate data today. I'm going to give you a rundown of my process. So I just have a simple Jupyter Notebook. So if you wanted to use Google Colab or something of that sort, you may be able to do it. I think that the trick here is if you're wanting to use large language models, if you're not looking to use something like OpenAPI and making a call out to them to where you can use their resources and their models, you'll need to host resources for running models locally. So I'm using Ollama, which is something I install on Windows and run locally. This is a local Jupyter Notebook instance. So the breakdown here, I'll start with the end state just to give you an idea of where we're going to go with this. So I'll scroll all the way down to the bottom, and I'm going to show you the output. So this is something that I got as an output with. This was with Llama 3. So we fed in a bunch of real estate data for a city near me and asked it to describe different things about the data set. So we pulled the data from Zillow and said, hey, here's basically just a pile of data that is presented in a natural sentence structure so that the large language model is more likely to understand it because it reads as a human would read. And it analyzed and provided a couple of different outputs. So this is sort of a market analysis, and this isn't even with a reasoning model either. This is just a tier below reasoning model. I haven't checked it for accuracy, and if you used a reasoning model, you could arguably get deeper results. And if you enriched and repeated this process or brought in even more context, you could definitely go a lot farther with this. But I prompted it to provide an output on where it thought the best size and efficiency for price, where investment potential was, any sort of geographic insights about different areas and neighborhoods that had particular property values. There were some interesting insights. There were some breakdowns where it said, hey, there are some streets, which I kind of locked everything down by street. So if you were listed on Roanoke Ave, for example, it would have your average price and your per square foot average. And, it's catching things like saying like, hey, on Roanoke Ave, some of the properties listed there, they might be considered hidden gems. So there's relatively low prices compared to other streets in the area. And this hasn't even begun to really do spatial analysis. But that is something that you could definitely pull into this too, because we're just working with Python. So if you want to work with something like GeoPandas, ArcGIS, etc., you could definitely go a lot farther to actually pull things in a certain spatial area and say, hey, look in this exact, maybe 3-mile bubble or something like this. But this is the end state. So this is a general kind of market assessment of everything I gave it. But let's go through how I actually got there to provide this. So I'm going to scoot up here. So what we did at first was we went to has data pulled from their Zillow API. We got a bunch of Zillow listings for Newport News, Virginia. Then from there, we just got this raw response. So the response comes in as JSON. We take all that data. It's got a variety of things in there, but all we're really worried about is price, address, city, state, zip code, beds, baths, that sort of thing. From there, we did is just cleaned up and formatted the data, put in a data frame, and then ran some statistics on it. Just really simple things. Just to say down here, what's the average price, median price range across that entire data set, which we then later broke down by neighborhood, which we'll get to here in a second. So from there, the real trick here is displaying this data in a way that is more readable, because if we go back up here, if I were to turn this data frame into a string and pass it into the large language model, it would not be received as let's say a first-class citizen. It would be not a format that would be treated kindly or understood well by the language model, because it's more keen to understand text, even though it can't understand data. And we do want to isolate some of the key items that are of interest. So for our context here, for our overall market analysis and for our street analysis, we don't really need the numbers for example, from the address itself. Those are basically noise. We don't want those to be confused with price or zip code or square feet or any of these other numericals that are in here. So when we move into the next step, we actually phase those out entirely, and that's where we begin to provide data that's more rich and valuable for understanding to the large language model. So from there, we go through and we begin to build out these more readable breakdowns here. So there's some more data framework here, but what we're doing is basically just building out this display field. So I'll show you these so that you can actually read them, because they'll be a little nicer. So down here, we combined an aggregate answer for each street or avenue or court, what have you, that extends about this long. So we would say something like 1x listing on 27th Street. Average listing for the street is 279,000. Minimum is this, maximum is this, etc. We just went down the line. So in some of these scenarios, you'll see there are groupings. There's a lot of onesie twosies, like only one for sale on the street. However, there are some situations where we have more than that. But what we did is we took all that and combined it into just one giant string. So you see this is all kind of slammed in here, but this is a better representation of the data than passing it as just like a pure table or what have you. And then we go to the question of, well, what do we want to do with this data? And the answer here is, well, we need to tell the large language model what to do with it. So we build a prompt. So what I said for the instruction is, hey, analyze the following data for each neighborhood by the number of listings. Find what neighborhoods or areas have the best value by any of the metrics provided. Please provide a detailed analysis addressing value patterns, size and efficiency, investment, geographic insights. Support all findings with some sort of evidence from the data. Flag anything that's particularly interesting across that area or any unusual patterns that you may discover. So from there, I basically just do an addition with the strings. Just take all of this data right here, that string, and then add the prompt, the instructions onto the end of it. From there, we go through and we use Ollama, and we'll query Llama 3, and we'll say, hey, take my prompt text, everything in here from the raw data that you're getting, and all the prompt instructions. And then from there, give me the answer. So at this point, we have essentially a macro level analysis purely based off of listing statistics and the names of neighborhoods for Newport News. Now from here, we could move to take this data stored in a separate database, then enrich it further with other details depending on what we have available. We could characterize the details of different neighborhoods with additional things like crime. Are there sentiments in the neighborhood? Are the community features that are desirable? Like, let's say there's a very active Little League community in one of these neighborhoods. That could provide indications that we could then have the large language model articulate that, hey, this neighborhood, it has really good value, low crime, and anyone who has kids that are in Little League, there's one right down the street. There's also good schools. And these are the types of things that you don't get from real estate data as it stands by itself. You can't get that by just looking at statistics. You can go and poke around Zillow all day, but this is where we can unlock a whole new level of data by combining and asking questions. And where do we ask the questions? Well, we ask the questions at the prompt instruction level. We say, I want you to take this data about the neighborhood, combine it with the real estate data, and then I want you to give a holistic answer. I want you to tell me a story of how the area actually is, what people say about it on Nextdoor or a Facebook group or what have you. So there's a lot of opportunities here to really enrich and build better data sets with large language models, and this is really just scraping the surface. So I just want to highlight this project. I think that this is a very preliminary exploration that I'm going to do into data combination with this type of technique, but I just thought it'd be valuable to share, and just wanted to give a highlight of what's possible. So if you like this, go ahead and drop a comment, like this video. Thank you so much for watching, and I'll see you in the next one.